So let us talk about the new concept called logistic regression. Okay, so logistic regression is basically used if the y, or the response variable, or we call dependent variable, is categorical. Okay, so in all the linear regression, simple linear regression, multiple linear regression, the y variable is numerical. There was numbers on the y variable data, right? But if y variable is categorical, then that linear regression does not work because it doesn't satisfy the assumption of the linear regression. Okay, so if it is categorical, then we use the another type of regression is called the logistic regression. Okay, so let's go over this. Linear regression predicts a continuous dependent, or the response variable, where independent variable could be numerical, that is metric, or categorical. So if the dependent variable or the y variable is a factor variable or categorical variable, we use the logistic regression. So before we start or dive into the logistic regression, what I want to do is I want to just introduce some of the terms that we use here. Okay, so the first thing is the odds. You guys know about the odds. Odds of x to y is the ratio of x and y, right? So if P is the probability of happening, then odds of happening is the ratio of probability of event that will happen and then that will not happen. So for example, what it says is if P is the probability of happening, then odds of happening is written as P over 1 minus P, because that the bottom one is 1 minus P is the lose, right? And P is the win or happening divided by not happening. That's the odd of happening. Okay, so the odds of happening or odds of winning is probability of winning divided by probability of losing. It's like that because 1 minus P is the probability of losing. Okay, so that's the odds of happening or odds of winning formula. So odd or odds for is the likelihood of happening. So if the if 2/3 odds of winning, so odds of winning is winning is is 2/3, then odds of losing will be 1/3, right? Losing will be 1/3. That means you see that the winning is 2 times more than the probability of losing. So you can think that way. So another example is, if the probability of winning P is 1/5, what will happen? What will be the odds if the probability of winning is 1/5? So P equals to 1/5, then the formula for the odds will be P over 1 minus P, right? So that will be what? 1/5 divided by 1 minus 1/5, right? So that will be 1/5 divided by 4/5. So basically, so you can write 1 over 5 times 5 over 4. That will be 1/4. So that will be odds of winning here will be 1/4. Okay, so if the probability is given, then you find the odds of winning. If this is the winning probability, then odds of winning is that one. If this is the losing probability, then the odds of losing is that formula. So that's how we can find out the odds of winning or odds of losing based on the given probability. All right, so the next thing is, if the odd is given, right? So then if the odd is given, then we can find the probability using above formula. So if P is given, then odds of P is given by P over 1 minus P, right? That's one thing. So another is, if you solve this one, then you can find out, let's say number 2 is, if you solve this one, what do you get? So basically what is happening here is odds equals to P over 1 minus P, right? If you multiply cross multiplication, then odds, right, minus P times odds equals to P. Now let's solve for P. Then odds equals to P plus P times odds, right? So factor out P, you get P times 1 plus odds equals to odds, right? So P equals to odds over 1 plus odds. So what do we get from here is basically P equals to odds over 1 plus odds, meaning that if odds is given, is given, then we can find out the probability using this formula. Okay, so that's what it is talking about. If the odds of an event is given, we can find the probability using P equals to odds over 1 plus odds. So that is for the odds for P. So if you want to find out the odd against odd against, then it is just the reciprocal of that. Reciprocal of the odd for is 1 over odds for, right? That is basically 1 minus P over P. That's the reciprocal of that thing. That's the odds against formula. Okay, so let us see one example here. If the probability of winning is 12.5%, so what it is given is, so here P is given as P equals to 0.125, that is given to you. Then odds for winning, then what is odds? Then odds equals to P over 1 plus P, right? 1 minus P, I'm sorry. So P over 1 minus P, that will be 0.125 over 1 minus 0.125. That will be 1 over 7 if you use the calculator. That is odds for P. But if you want to find the odd against P, so you can write odd against equals to 1 minus P over P. So basically reciprocal of that, 7 over 1, that is 7. So odds for is 1 over 7, right? Odds against is 7 over 1. That means, so the probability of winning is 1 out of 7. So the probability of losing will be 7 times more than probability of winning. That's what we were talking at the beginning, like times. If it is given odds for and odd against, then you can basically describe like what times more winning chance than the losing chance, right? Okay, now the logistic regression here. So here what we are saying is, depending on the number of levels in the response variable, we use different types of logistic regression. As we said that logistic regression, the response variable, in the logistic regression, response variable is constant, right? Is constant. Okay, so response variable is, in logistic regression, response variable is not constant. I'm sorry. Response variable is categorical. Response variable is categorical, right? So since it is a categorical variable, it may have 2 levels or 3 levels or 4 levels, right? So Y has levels like male, female, or yes, no, or success, failure, those kind of levels, right? So Y will have that type of data. Y have levels. So if Y have 2 levels, then that is called binary. If it has just 2 levels, it is called binary. And then if there are more than 2 levels, it is multinomial. Okay, and there may be ordinal logistic if there is an order of the, for example, if you like agree, disagree, strongly disagree, those kind of levels that has ordering, then that is called the ordinal logistic regression. But in this course we will be talking about the binary logistic regression only. Okay, that has just 2 levels. So we mainly cover binary response variable. For example, depending on the symptoms or the lab results, what is the chance or the probability that person has a cancer, or what is the odds of having the cancer, right? The result in logistic regression is expressed as the probability of being in 1 or 2 levels categories. So the value is always between 0 and 1. That's what the probability, because we will be talking about the probability of winning, probability of losing. That's what the outcomes from the logistic regression, right? So all the values of the response variable will be between 0 and 1. Okay, so what is the equation for the logistic regression then? So that's how we derive the equation. So P is the probability of winning or probability of having Y equals to 1, because the Y variable is categorical, right? So for the categorical Y variable, there may be X variable. We'll be writing instead of male, female, or yes, no kind of variable or the values of Y, we write 0, 1, 1, 0. So we denote by 0 and 1. Okay, so the Px is the probability of having Y equals to 1. So Y equals to 1, given that X is already there, is the probability of Y equals to 1 given X. Then the logistic function of Px is given by the formula for px is given by this formula, e to the b0 plus b1x over 1 plus e to the b0 plus b1x. This is the formula for the probability. If y is a binary variable, y has 0 and 1 as the data values. Okay, so if you simplify this, equation, then we get, so if you simplify that equation and then solve for e to the b0 plus b1x, then you get this, e to the b0 plus b1x is equals to p over 1 minus p. Basically, if you do p over 1 minus p, that's what you get. Okay, and then now let us take the log on both sides. What do you get? You get, because if you take the log here, ln, right, like this, so you will get ln and you will cancel out, so you will get what, b0 plus b1x is equals to ln p over 1 minus p. So that is basically the logistic equation. Okay, so on the right hand side you got ln p over 1 minus p, that is called log odd, because this value is odd, right? This value we call odds, so log odds, so that is log odds of p is equals to b0 plus b1x. So in the linear regression we had just y on the left side and then b0 plus b1x on the right side, right? But in the logistic regression, on the left side, instead of y we have log odds of the p, log odds of p, and this is also written as log it of p equals to b0 plus b1x. Okay, so this is called the logistic model. This is called the logistic model, the first one or the second one. Okay, and where x is the independent variable or the predictor variable. Now how do we interpret though? How do we interpret the result? So let me cross that one and then let me open the new file there. So what we just saw is log odd of p is equals to a0 plus a0 plus, or you can write b0 plus b1x, or you can write log of p over 1 minus p equals to b0 plus b1x. That's the same equations, okay, just the different notation. And there is another notation, log it of p equals to b0 plus b1x. So these are the same equation but writing in the different format. Okay, now how do we interpret the result? Because if you remember that in the linear regression excuse me, in the linear regression, how did we interpret? Because there used to be y in the linear regression, if you remember that. There used to be y, right? So we were interpreting for every 1 unit increase in x, y will be increased by b1 unit. That's what we were interpreting in linear regression. Or if x is the categorical, then if x is a category, let's say male, then you say that male has b1 unit higher y than female, right? That's how we used to do. But here we do not have the y. Here on the left side we have the log it of p, or we call log odds of p, right? How do we interpret that? If we increase x by 1 unit, right, then the log odds of happening, that's log odds of the probability increased by b1 unit. So instead of y we write log odds of p. Okay, that is for every 1 unit increase in x, log odds of p increased by b1 units. That's how we interpret the result. Now what that means is log of p over 1 minus p increased by b1. That's what you see. Now if you want to solve for p though, what will happen there then? So p will be what? So p will be increased by, so that you need to get rid of log first, that will p over 1 minus p will be increased by e to the b1, right? And if you solve for p, then you will get what? If you solve for p will be e to the b1 over 1 plus e to the b1. So you can find out the probability of increasing by solving that way. Okay, so but we will not do by hand, all these things will be done in R. So what is the R command for the logistic regression is, you write GLM, generalized linear model. Previously we used to use LM only, but now here it is GLM. Y, the Y variable must be first, and then tilde, and then X variable, and you write family equals to binomial. Data is what data we are using. Okay, that's what we'll be doing in R. So I will show you one example there in R. Let us see that the data. So what data we are talking about on the example is, the data is taken from Vanderbilt Biostatistics data repository. The data abm.xls is converted into .csv format, and only 3 columns, race, WBC and ABM, are selected for illustration purpose. Here ABM equals to 1 means the patient has acute bacterial meningitis. Otherwise ABM equals to 0 means the patient has acute viral meningitis. So we have the like different data for ABC, and then so race, WBC and ABM. So race is what race the patient is, WBC is numerical value, and ABM is does the person has acute bacterial meningitis, that is 1, and does the person has the acute viral meningitis, that is ABM equals to 0. Okay, so first what we do is we read the data and we select those 3 columns, right, and we remove the NA values, and also there may be some blank values. We will be removing those rows of the blank values only. Okay, and then what we did here is, let us first run the logistic regression. Model 1 equals to, you have GLM factor. Again, the Y variable is categorical, that's why we are writing factor ABM. So ABM column on this data set has 0 and 1 values, right? So that's why the R may be thinking, considering that as a numerical, that's why we told R that it is a factor. And tilde WBC, and data equals to D, we are denoting that by D, and family is binomial. So the model you get will be, this is the model you will be getting. So B0 plus B1x, so log it up P equals to B0 plus B1x, that's what we found. So how do you interpret the result is, for every 1 unit increase, because WBC is a numerical numerical X value, for every 1 unit increase in WBC, the log odds will be increased by 0.1430. Okay, and if you want to find out or predict the value of the so if you want to predict the probability, right, if you want to predict the probability for a person with WBC 7.4, you can just plug in WBC equals 7.4 and then just solve for P. That's what you get. When you solve for P, we use that formula, right? We use that formula to find out the P. We use this formula, you see that, to find out the P. But when you say like increase or decrease, you just use that one. So when you increase one unit increase in X, how much the probability will increase? If the question is asking like that, then you use that one. But usually we don't need this one. Usually we find out the probability of a person has the acute bacterial meningitis, ABM equals to 1. If the person has a WBC equals to 7.4, what is the probability that the person has a ABM? That's how we find out manually. Okay, but but usually we don't find out manually. We just use R to find out that. Okay, let us see that example in R. Okay, so this is the data set. All right, let me make it a little bit bigger just to make sure that you can see it more clearly. Okay, so this is the data set, right? And let me clear that one as well. So Control L. Okay, this is the data set, and this is the head of the data. There are so many columns, right? And there are so many NA values. So how many data set are there? 581 rows and 43 columns. So I am using the library deploy R to select. So B, I'm giving a new name B, where I'm taking the columns from A. I'm picking only 3 columns: race, WBC and ABM. All right, and then I'm removing the NA values in the B, and also let us see how does it look like. Look at that. When I put the head of C, where after NA removed, but there are some blank values. You see that? There are some blank values. So we are removing the rows of blank values as well. That's what we say. Now we run the logistic regression. Model 1 and is the name I'm giving, GLM, and factor ABM, that is Y, and I'm giving a command factor. That means that if Y looks like a numerical, so you see that ABM look like a numerical data, but it is not actually numerical data. 1 stands for the person has the bacterial meningitis, and 0 stands for the person has the viral meningitis. Okay, that's why although they are representing numbers, ABM is represented by numbers, it is like yes is 1 and no is 0, like that. So it is a categorical. That's why we are writing factor ABM, and WBC is the independent variable or the predictor variable. Data is D, that's what the D data is, and binomial. Okay, let us see what we got. So we got this value. Look at that. WBC has, as we saw that earlier in the slide, this intercept is that one, and then WBC is that one. So what is the code we got? I mean, what is the equation we got there? Is Y equals to A plus BX, negative 1.7634, and then plus 0. Not Y equals to, I'm sorry, this should not be log Y equals to, it should be log it P equals to, not Y equals to. Y would be for the simple linear regression, right? So it is logistic. So 1430. So that is the logistic regression equation. Does that make sense? So that is the logistic regression equation. Now, and it is also, you see that p value is significant. That means this value, this coefficient is significantly different from 0. So let us go back. So how do you interpret the result? I have interpreted that for every 1 unit increase in the WBC, the log odds, that means log p over 1 minus p. That's what the log odds means, right? That is, so of ABM is increased by 0.143. This means the odds, that is, odds means what? That is, odd is increased by 0.143, and the probability of acute bacterial meningitis increased by, so I was just doing the same thing that I'm doing right here, e to the b1 over 1 plus e to the b1. Okay, now there is a question saying, find the probability of ABM, not AVF, find the probability of ABM for a person with WBC 7.4. What is it asking? So what it is asking here is, if a person has a WBC 7.4, what is the probability that the person has a acute bacterial meningitis? That is ABM equals to 1. That's what it is saying. So that is, if a person has a WBC 7.4, what is the probability that the person has the acute bacterial meningitis? So if you want to do manually, then you can do exponential of, you see that, e to the a plus bx. So p equals to e to the a plus bx over 1 plus e to the a plus bx. That is manual way of finding, right? But if you want to do it directly using R, that is predict, model 1 is, that is the model 1, right? Data.frame WBC equals 7.4, types equals to response. That's what we got, and either way we'll get the same, very close, right? Because it is like how many decimal places you see, so it is giving the same result for 4 decimal places. So that is the probability that a person with WBC equals 7.4 has the acute bacterial meningitis. Okay, so that is the case that where WBC was a numerical predictor, right? But sometimes your X will be categorical predictor. For example, in model 2, you see that in this data set, right, race is categorical, WBC is numerical, ABM is also categorical. That is the Y variable, right? Excuse me. Now, how do we run the logistic regression if the X variable is categorical? So here, exactly the same way we do, I'm giving a new name called model 2, GLM, factor ABM, that's the Y variable, right? Tilde race is the X variable, all other codes are the same. So let me run that, and then this is what I got. See that? Race white, because the race has black and white, so it is missing one of the level, that is the black level is missing, right? So how do you interpret the result? Compared to the black race, the log odds of ABM in white is increased by 0.05. You see that? Compared to the black race, or you can say that white people have 0.58 higher log odds than the black people. Log odds for the acute bacterial meningitis than the black people. That's what it is saying. Okay, compared to the black race, the log odds of ABM in the white is higher, not increase, let's say higher by this. But this is not significant. Look at that. The p-value is greater than alpha, so it is not significant. So how do we interpret because this is for the log odds. That interpretation is for the log odds. But how about for the odds? So the odds, odds is higher by 0. So what we see here that log odds, right? So it is log odd. Let me log it of p equals to b0 is negative 0.1852, 0.0, and then plus 0.5879 times wide, race wide. This is what we got. So how do we interpret the result? It means like white have 0.5879 log odds more. So let's say this way. So the race white has 0.5879 more log odds of acute bacterial meningitis than black. That's how we say, right? So you say that white race has 0.5879 more log odds of acute bacterial meningitis than black race. That's how we interpret the result. So this is for the log odds though. If you want to say, because this is log odds of p, which is same as p over 1 minus p. It is like log of p over 1 minus p, ln of p over 1 minus p. It goes up by 0.5879, goes up by 0.5879. But if you get rid of the log, then you will get odds, right? So odds equals to p over 1 minus p goes up by e to the 0.5879. And if you solve for p, then you can say p goes up by e to the 0.5879 divided by 1 plus e to the 0.5879. That's what I was doing here. So what we got is 5.55%. Now the thing is, as we did in the last example for the numerical x value, so if you want to predict, find the probability of ABM in black race. Okay, so you don't need 4 here. So what is the probability of the acute bacterial meningitis in the black race? It is, what we do is, if you want to do it manually, you just plug in black race equals to, so because our equation is for the white, so if you white equals to 0, then that the remaining result is for the black. Okay, so that's what we are doing, negative point that, and then this times, instead of white we write 0. White equals to 1 means for the white race, white equals to 0 is for black race, right? That's what we do. But if you want to do it directly using R, then you do predict model 2 data.frame race equals to black, because we are finding for the black race, and type equals to response. So you will get very similar result in both of the method, manually or R. Okay, for the white race you just take 1 for the instead of white we just replace by 1 to find out the actual probability. Okay, that's how we find out. Okay, so the very last thing here is, if the logistic regression has multiple x variable, multiple predictor variables, then the idea is very similar to what we did in the multiple linear regression. So you do GLM, and then factor ABM is the y variable and change to factor, and then you do race plus WBC and so on, and all other remaining code is the very similar. So if you run the summary, this is what you get. And how do you interpret the results? So to interpret the result, you can say that, so let me write down the equation first. So equation is what? So let me write this way, log odds of p is equals to, it will look like this is b0, right? b0 plus this is b1 times white, right? So this is b1 times race white plus and then let me write down, we don't need plus, this is minus, right? So and then plus this times WBC, so that number times WBC. That's what the equation, right? How do you interpret the interpretation? Interpretation interpretation of that is race white has negative 1.76, let's say 5 lower log odds of ABM then race black, keeping because it is a multiple linear regression, right? Keeping all other constant. Similarly, how do you write the how do you interpret the WBC? Okay, for because WBC is numericals, for every one unit increase in the WBC, right, the log odds of ABM increase by 0.143. So this is the interpretation. So this interpretation is based on log odds. Did you see that? These interpretations are based on log odds. But if you want to, by the way, keeping all other constant, you cannot forget that. Keeping all other constant. Okay, so that's how we can basically interpret in terms of the log odds though. But if you want to write in terms of by the way, race, right? If you want to write in terms of odds only, then you need to take the exponential. So what is the another way of doing that? So let me write down that in terms of odds only. Okay, so how do you interpret that in terms of odd then? So you will be writing, let's say, race white has exponential e to the that lower odds, not log odds, because we removed the log and we took the exponential on both sides. And then for every 1 unit increase in WBC, the odds of ABM increase by e to the, that's the, like that. Okay, that's how we interpret the result. But if you want to find out the probability again, so for example, interpret the result and also find the probability of a person with WBC equals 7.4 to have acute bacterial. Oh, by the way, let us see here. Let us see, I have done here. So question is, find the probability of ABM for a white person. The person is white and WBC is 10.3. If the white person has a WBC 10.3, what is the probability that the person has an acute bacterial meningitis? So how do we do it directly using R? Is predict model 3 is the model that has a multiple predictors, right? Data frame, race equals to white, WBC equals to 10.3 and type equals to response. So if you want to do it manually, that's what you do. You just replace, because what is our equation? Our equation is like that, right? That's our equation, right? So you will replace race white by 1 and then WBC by 10.3. So that's what I'm doing here. All right. That's how we derive the multiple logistic regression as well as the prediction using the multiple linear regression and its interpretation. Okay, guys. Thank you.